All right, well, good evening, everybody. We're gonna get started. I'm sure we'll have a couple of late arrivals, and that's fine. Welcome to Why Engineering, our third rendition of Why Engineering. We'll give you a quick introduction. We'll have our panelists introduce themselves, and then we'll get into questions. Again, thanks for coming, everybody. It's programs put on by the College Counseling Office. Mrs. Rigner's in, Mr. Duffy is here, and I'm Mr. Boehm. I know we actually have some future AUKs in the webinar today, some 8th graders, some rising 9th graders. We're excited to have you as part of our community. Hope you enjoy the program tonight. The Why Engineering and actually Why Career series, we rotate through 4 different large career fields once every year. So in a 4-year cycle, the Why Engineering program was birthed from Mrs. Rigner and my first year at Archmere, when we talked to a whole lot of engineers and asked them. We always ask the question, why do you want to do what you think you want to do? And we believe that there's a big power in why, not only in applications, but also the self-confidence of the student. We got a lot of, I really like math, I like to problem solve, and I did really good in physics. And we wanted to give our students the tools to be able to further articulate that, not only to themselves, their parents, but also an admission counselor, an alumni interviewer, or an application essay. And this is the start of that. Students can find out a lot through their network if they're curious. We're going to take a couple minutes, allow everybody to introduce themselves, what their background is. I think you'll see that we have a phenomenal panel. Dr. Hewlett, can you kick us off, please?
Sure. Hi, everyone. I'm Dr. Sheldon Hewlett. I'm a professor of material science and engineering at University of Delaware. A little bit about me. I am actually originally from New Jersey, so fairly local. I got my degrees in material science and engineering. My bachelor's is from MIT, and my master's is from Northwestern, and then I have a PhD from Central Michigan University. I primarily, actually these days, spend a lot of time teaching. I am essentially sort of a teaching professor at UD, and I also coordinate our very new undergraduate program in material science and engineering. And it's my absolute pleasure to be here today with you.
Oh, thanks for coming tonight. Andrew?
Hey, good evening. Let me share my screen real quick. So, yes, my name is Andrew Zito. I'm from the Boeing company. I'm in the Boeing Defense Space and Security Vertical Lift division, particularly in the mission systems arena as a system and software engineer. I'm also an integration and test engineer, as well as a Boeing technical lead engineer at the Boeing company. I've been with the company for 20 years. My roadmap as far as my career goes is as such, where I started as a co-op and at the RAH-66, which is a reconnaissance attack helicopter, and embedded software engineer in 2000. I spent 2 co-ops at the Boeing company, in which case I was hired full-time and continued on with the RAH-66 attack helicopter until 2004. Then I switched over to V-22, and that's my current assignment as of today as a software engineer. I also have the luxury of participating in other platforms, such as the Apache 64 attack helicopter and mission systems, and the JMR mission systems architecture demonstration. As far as my educational background, I have my bachelor's and master's in software engineering, master's of science in computer engineering. Graduated from Drexel in 2003, master's in 2009. I've continued my education at Penn State with a master's in engineering and system engineering in 2017. And I have sprinkled various education with Villanova, California State Fullerton, and a bunch of other universities. I'm also a mentor. I know Archmere has a mentor, FTC team. I'm a mentor from O365 back in 2006 until today. So I have a bunch of students. I do have one student that's an Archmere student. She is currently, I believe, a sophomore in our team. My hobbies, a little bit of everything: 3D printing, Lego, Japanese animation, DJI drones, GoPro with video, photography. So a little bit of gamut of everything. And I'm happy to talk with you guys today.
Terrific. Thank you, Andrew. Shannon?
Greetings, everybody. My name is Shannon McCullough. I'm a Senior Assistant Director of Admission at the Office of Undergraduate Admission at Carnegie Mellon University. In the office, we don't really have a set thing that we read for, but I've read for our engineering program for a couple of years, especially when I first started. Here at Carnegie Mellon, we have a lot of interesting programs in 6 different undergraduate colleges, but our College of Engineering is definitely our largest one. About 400 students we bring in every year. We have a couple different engineering programs, or 5 different traditional engineering programs, and I'm glad to go into them later, but it's definitely something our school focuses on. I also graduated from Carnegie Mellon. I got my degree in material science and engineering, and I'm here now to present to you.
Thanks, Shannon. We saved we saved family for last, My'Kelya. You're up.
Hi, everyone. My name is My'Kelya Dickerson, and I graduated from Archmere in 2015. And then I went to Lafayette College. While I was at Archmere, I did lots of things. I was in several clubs and student council and on the cheerleading team. And then I continued some of those things at Lafayette College, where I was also on the cheerleading team, and I decided to study chemical engineering with a minor in French. And then after graduation, I went to a company named Siemens, and I worked in business development, sales, and marketing. And then after that, I decided to do a more technical role where I am now at a company named Airgas, and it's exactly what it sounds like. We sell air. And so I'm in a rotational program. And actually right now I am on my way to my next assignment in Houston. So I'm in Chattanooga, Tennessee on my way down there. So I'm happy to share anything about that if there's questions.
And thanks for joining us tonight, My'Kelya. I know you're traveling. I'm glad you were able to squeeze this in. Great to have you. So the format tonight, folks, those of you in the webinar, we have set questions for our panelists that they're prepared to answer. They're going to particular panelists, but we're also going to have the Q&A function open, and Mrs. Rigner is going to man that and probably answer some directly, but also make us aware when we have questions that are getting voted up and or being asked in different ways. So we'll go for about 45, 50 minutes. And then we'll allow our panelists to kind of wrap things up with what they think are important messages from kind of the flow of the questions today. I'm going to start off. We're going to throw a nice little softball question up here. I'm going to ask Dr. Hewlett and Andrew. We'll start with you, Andrew. Why would someone want to be an engineer?
Because it's fun. It's exciting. So no joking aside, but you want to be an engineer because you love to problem solve and you love the challenge. So challenging jobs is making you realize the ideas. So it comes into fruition. Anything you can think of, any concepts, you can realize them. There's a variety of engineering positions, right? So there is, ranging from computer engineering, mechanicals, chemical, civil, architectural engineering, nano engineering, all that kind of stuff. Of course, excellent pay and benefits at the Boeing company. We have lasting and tangible products. So where I work at the Boeing company, we make the CH-47, which is a Chinook helicopter, cargo helicopter. We also do the V-22 that service the Marines and the Navy and Special Forces. We also help humankind. So we develop products that allows our soldiers, our troops to defend and protect. And at the same time, we're making sure that they're safe on the platform that they fly into. So we make a world of a difference.
Terrific. Dr. Hewlett?
Yeah, I think that was actually summed up quite nicely. In fact, on my notes, the first thing I had is engineering is fun, which I really think it is. There's something kind of magical about being able to create in the way that engineers do. Using sort of the bedrock of math and science, we get to make things that have never existed before, which is a really exciting thing about engineering. You get to be someone who has doing something that nobody else in the world is actually working on, or nobody else in the world is able to do exactly the way you're doing it. That is a pretty exciting and fun thing about engineering. It's indeed very challenging, but I think one of the nice things about engineering is when you rise to the challenge, you get to have a real impact, as Andrew said, on the world. Everything that we touch, everything that we interact with was probably worked on by an engineer at some point. And having that kind of impact on the world is, I think, a really meaningful thing. And also, not to put a to find a point on it, the pay is good, and you can't ignore that. That is something that I think is certainly worth considering.
So now that will return that everyone should want to be an engineer. I'm going to ask Shannon, what type of a preparation for admissions to an engineering program is CMU and other schools looking for, and are there engineering majors that are more selective or have different requirements than others?
Yeah, for sure. So one thing I always tell students in general is every university is different. Even if they look and tell you that they're the same, they're different. So whenever you're looking for a university to spend, your 4 to however many years, if you're getting your PhD, your master's or things, you got to look into each one because they have different fits. I would say for engineering in general, you have to like engineering, right? Like that's a very big thing. You have to enjoy what you're doing at the school. Of course, engineers, as sort of stated, tackle problems in a variety of different ways. So having a solid background in mathematics, having a solid background in a lot of the sciences usually helps. Depends on which engineering you're going into, right? So if you are doing materials engineering, you're probably going to have to like chemistry a little bit much. If you're doing mechanical engineering, you can skimp on the chemistry a little bit. So it really depends. And the good thing about that too is if you're like, hey, physics is really where I like to be, there's engineerings that focus heavily on physics. If you're like biology is even where I like to be, there's engineerings that focus more heavily on biology. So making sure you're taking math and science that you're interested in and that's challenging you and that you're doing well in always helps. I would say also as far as whether some are a little bit more harder to get into than others, that depends school to school. So for us, our electrical and computer engineering program is our second most difficult academic program to get into for the school as a whole, and is the most sort of rigorous and selective program at the university. And then probably our mechanical engineering. A lot of people want to be mechanical engineers. It is really exciting. And then after that, they all fall in after. They're still within the same band. So, don't get too upset if you're like, oh, I really want to do electrical and computer engineering. But there are some that are different and every school is different too. So make sure you do your research on your schools.
Now, Shannon, to talk about the diversity of CMU, I'm assuming the most selective program is something in the performing arts. Would I be correct?
Actually, yeah, you are. The most selective program by the numbers is probably our drama program. We get thousands of applications and they bring in a couple dozen students. So that, and then our most selective academic program is probably our computer science program. And after that, there's programs that are spread out. And that's one thing that's really exciting about CMU is that you do have a lot of different people with a lot of different strengths and a lot of different ways of thinking that come together. So you're going to talk to a lot of engineers if you're an engineering student, but in the dining halls and the dorms, you're going to be around a whole bunch of other people, which just makes your problem solving ability a lot better.
So sorry, everybody, that got off topic. I got into the arts, but I wanted to see if I was correct in that assumption. My'Kelya, we're going to come to you. I'm going to add a little bit to this question because I think it would be a great story if you could share how you decided to be a chemical engineering major. And then if you could also dive into how well prepared you felt you were for the coursework at Lafayette. And in hindsight, would you have done anything differently, either academically or extracurricularly at Archmere, that you may have felt would have better prepared you for your curriculum at Lafayette? I think I have 3 questions in there. So if you need me to get back to any of those, let me know.
Okay, yeah, you'll have to let me know if I missed something. But I'll start with why I chose chemical engineering. For me, I was not the person that knew that I wanted to be an engineer when I was 3. I didn't know when I was 17 either. So when I was approaching my later years of high school, I kind of was thinking, well, I'm pretty good at English and I'm also pretty good at math and sciences. So I don't know which way to go. It wasn't one that I felt more passionate about at the time. And my mom kind of was in my ear. You should do engineering, just a typical parent. And I was like, oh, well, we'll see. Well, I'll think about it. And I really couldn't come to a decision. And so what I did decide was that engineering, if I changed my mind, was easier to get out of if I changed my mind than it was to get into. And so I said, I'll start with engineering. And if I don't like it, I'll switch out. And I said, that's pretty difficult. And then I said, okay, as far as choosing my discipline, I simply just asked someone, what's the hardest discipline in engineering? And they're like, probably chemical. You can't see anything. And I was like, sounds like a good place to start. So I applied to chemical engineering programs because I like a challenge. So as someone mentioned that earlier, if you like engineering, it's probably because you like a challenge. And I am one of those people. And I was like, I like a challenge. And if I don't succeed, then there's another path. It's not rejection, it's just redirection. And so I was like, I'll do it and I'll see what happens. And lucky for me, I was fortunate enough to make it through the whole program, and I am a chemical engineer. But it was not the traditional story of knowing exactly what I wanted to do, but I did end up at the exact right place. I didn't know what I wanted to do, but I knew who I wanted to be, and I knew I wanted to help people, and I knew that engineers did that. So this fulfilled the desire to help people for me while also using my brain and intelligence and gifts and things like that. As far as Archmere preparation, 100% without a doubt, I was prepared for college. I noticed when I went into my freshman year very quickly that I was much more prepared in different ways. So, for example, writing style. Archmere is really good at English and writing style in addition to the math and sciences. And so I was able to not only do the numbers, but I could communicate the numbers, which is really important as an engineer. And even in core classes, I had friends say, you're really good at grammar. You really pick up on things. Can you help me? Can you read over my paper? Can you do this or can you do that? And I kind of became like a supplemental teaching assistant. And so I quickly realized that not everyone was prepared the same. We did a lot more work at Archmere than some other schools did, or just different work that was more similar to the college atmosphere. And I had a lot more um, availability to plan my time better. I think some of my friends in my freshman year didn't know how to manage their time. And one thing Archmere did was teach me how to manage my time. I had so much work to do, and I had to figure out how to get it done. And so Archmere definitely prepared me for that. I think there was a third question in there. What am I missing? You're on mute.
Yep. If you turn back the clock and said, boy, was there something that I could have done in high school that I didn't, that would have better prepared me for college in general, but also for the engineering program?
Yes. So I'm gonna go with no, just because I think that my experiences are make up who I am today, and I really appreciate everything that I have done, and maybe the things that I missed out on were things that I was supposed to miss out on. But I don't feel like I was gypped in any way or I made a poor selection. I felt like there was a lot of guidance at Archmere. If I ever expressed an interest or a desire, there was always a teacher there or a friend or a counselor that was willing to talk through it with me and figure out the best plan of action, or we just can be a bug in my ear. I felt like I had a really great experience, and there's nothing that I would change about it. Like I said, I didn't know what I wanted to be, but I knew who I wanted to be. I think it was more important to have a sense of self and then go from there. And then the what I wanted to be would come from that. So I feel like my experiences helped me have a sense of self. And then from there, I was able to decide what I wanted to do and how to do it.
Thanks. Great words of advice. Dr. Hewlett, can you talk about freshman course loads for engineering students? And I guess it would be a fair question to ask if a student knew the direction that they wanted to go in, would it be different uh, compared to a student maybe that was, I know I want to do engineering, but boy, look at all these options that I have. I don't know which area I want to go into.
Yeah, sure. So there are some core classes that most engineers have to take. So at UD, and I'm going to speak mostly for UD. This may be general across the board for other universities, but my experience is with UD. You start out with having to take, everyone has to take English class, for example, right? A standard course that everyone needs to have. You have to be able to communicate your ideas. Intro to Engineering is a course that all engineering freshmen have to take at UD, and it is a course essentially that allows you to sort of see all the different flavors of engineering. You learn about engineering ethics and sort of the broad general design principles of engineering. someone who is unsure about engineering, that would be a good place for them to sort of learn and experience and see all the different types of engineering that's available. I will also say that almost regardless of any kind of engineering you do, you're probably going to need to have a full set of math courses. So a freshman in engineering is going to take some level of calculus. Most start at Calculus 1. A few of our programs bring in students where they're expected to have already taken Calculus 1 as a high school student, so they're starting at Calculus 2. But most of our programs require students to at least be at Calculus 1 when they join. And so that's something you can expect across the board. Calculus is the language that we use in engineering. In addition to that, most of our programs require at least one semester of chemistry, so most students take that their first semester. And anything else? Then you get some variations in the different types of engineering. Some might require a physics class to start. Some might require a biology course. So for example, our biomedical engineers have to start with a biology class as well. And also a computer science course. Everyone generally has to take a computer science course because that skill is becoming much more important. It's becoming almost fundamental to engineering, what engineers do.
Thank you. We have an interesting question from the Q&A from someone. Why would someone want to do major in chemical engineering rather than the pure science? And I guess we could compare that to any other of the engineering fields. But so however and I'll throw this out to anyone on the panel in terms of why engineering, why chemical engineering or any other area of engineering as opposed to the pure science.
I would say the way that I've always looked at it and the way I speak to students about it is a lot of times the pure sciences in my head, and a lot of people, is for the sake of the science, right? Like you are learning why things work the way that they work, or finding out novel ways in which things work, and really figuring out the fundamental forces behind everything. Engineering does do this to a degree, but it's also then taking these things and then using them for other things, right? Practical knowledge. So a chemist might say like, oh, I found this really cool reaction and I can make it in my lab and here it is, and I can reproduce it a bunch of times. And then a chemical engineer might take that and say like, oh, that's cool. Now, how can I scale that up to a nationwide set of reactions? Or same thing, you might be doing something in chemistry and you're like, oh, this is an interesting property of this metal or this material. This is really cool. And then the materials engineer might take that and say, like, okay, I want to use it to do X or Y or Z. I would say engineering a lot of times is just the application of a lot of these concepts, but it does get a little gray some places because engineers do research as well, right? So, but I would say if you're in it for just the sake of the science and figuring out these new novel things and being at the forefront of the science, the pure sciences are where it's at. And then if you're in it for taking these ideas and then applying them to different things, then the engineering is probably where you'd look.
I'll agree with that. Chemical engineering, I can speak for myself, is like you said, it's more on the application side. So when I think of pure sciences versus engineering, I think of a chemist can build me parts. They can build me, and this is a loose analogy, but they can build me an engine, the tires, the wheels, the seats, but I can build you a Corvette as an engineer. I can put the pieces together for you and I'll show you how it works. I apply it to the world and how people use it and need it. And sometimes the pure sciences are more in a different scope. Just, I don't want to say limited, but it's a different scope. They kind of go to a certain extent. They do the research. And like you said, that there is some crossover with research with engineers as well. But a lot of times engineers are more focused on how does this fit into the real world as well.
Yeah, I would agree with everything that they said, that Shannon McCullough said. I think that science is really the study of the natural world, right? So so what science essentially do is they ask the question, why? Why is this happening? I think what engineers do, they ask the question, okay, what's next? They look at what can you do with this after the fact. They apply all the things that the scientists have developed. And as Sharon said, there's a lot of gray area here, right, between science and engineering. In particular, in the field that actually Shannon and I both do in material science is often called material science and engineering because we kind of do both things things. We study the natural world as materials as they are, but then we also apply what we learn to make new materials. So we can kind of do both those things, but there is a separation as far as the sort of mindset and approach. Engineering has a lot more of a design approach to it, and science is always asking the question, why is this happening?
Terrific. Andrew, I'd like to get you back involved. Would love to know what type of engineers Boeing employs and what qualities do you look for in a strong candidate, I'd say beyond the engineering background?
So we do accept a whole gamut of engineering. So aerospace engineering, chemical engineering, you name it, pretty much all disciplines. The focus in my team is more in the software realm. So we've been, focusing on the software engineering realm or the computer science realm. But we do have mechanical engineers who have somewhat of a software background, who has taken either Java, Python, or C++, and they are also writing software for us. So it's not necessarily, per se that, okay, you're a mechanical engineer, you can't write software, anybody can do it, as long as you have the skills and background to do so. So yeah, we definitely take and accept pretty much any forms of engineering. And if you look at some of our job classifications, some of them, most of them probably say a bachelor's of science and engineering. So as far as what we look for, so I'm not a recruiter. I'm pretty much conveying information to you. What we look for is basically a good understanding of technology. So more than the computer literacy, understanding a systems approach. So think of things like how the system will work together, how all the pieces will work together. Don't think one piece cannot work together. Everything has to work together. Definitely a basic understanding of economics, history, the environment, the customer social needs, good communication skills, have a high ethical standard. So we have to trust you, right? So we have to make sure that you, are going to do your job. You're going to enjoy doing your job. We also, look for curiosity and desire to be part of a team and the desire to learn. Definitely critical creative thinking skills, and then the flexibility to work in different hours and different times of the day. We do have, engineers that have actually turned into managers. They have also went into the business aspects, but even that, they still have a technical background so that they can still approach a business perspective and try to talk with the customer and then show that, we can do this based on a technical approach.
Terrific. Thank you very much. So I'd like to talk about get into a little bit about kind of different educational deliveries and philosophies in engineering programs. So I'd like to start with you, My'Kelya, and talk about your liberal arts background at Lafayette. And then Shannon, if you could follow that up with how a CMU curriculum and maybe even mission or philosophy of the engineering program might differ slightly from the Lafayette experience.
Sure. So Lafayette College, if you're not familiar, is a liberal arts college known for engineering specifically. And not too many liberal arts colleges are, but Lafayette focuses with their philosophy that every person needs to be well-rounded. Every student needs to come out well-rounded. And so part of that is I was not able to just take simply engineering courses. I had to, in addition to, regular common course of study, take engineering classes as well as humanities classes. And the college regulated how many courses each person took outside of their major. So I was required to take 2 humanities classes. I was required to take 2 social science classes. I was required to take a language in addition to my engineering classes. And that was for everyone across the school. No matter how many classes you had or courses you had to take a certain amount of courses outside of your major to make sure basically you were using the other side of your brain, quote, quote. And the same thing went for humanities majors. They had to take a natural science elective as well. And they had to take a lab and things of that nature. And I think that really, really has paid off. And I think it's really helpful because I noticed when I looked at some more technical institutions for colleges that were simply and purely engineering, some of those people that I met outside of that were not very able to communicate or articulate their thoughts. And I feel like between Archmere and Lafayette, I learned a lot of writing skills, communication skills, and ways to facilitate information. So it's great to be an engineer because it's great to be really smart and know how to do something. But what good is it if you know everything, you can't tell anyone or share it with the world? And so I think the value in having a philosophy that is a well-rounded student is that you're able to think of these great ideas, put them together, and communicate them with others.
Yeah, so I think Carnegie Mellon is a tiny bit different, but it can be very similar. So at Carnegie Mellon, because you're applying, so when you apply, you're not applying to the university as a whole, you're applying directly into one of our colleges. And one of the benefits of that is that you get started in your work a lot quicker. So if you come in for engineering, you're going to be doing engineering work from the beginning. Now, you can try your hardest to just do engineering and you can get pretty close, but there is a common core that they make everyone take. Like everyone at the university has to take a writing class. They will make you take courses as well outside of those traditional engineering courses. When I was there was a breadth and a depth that you had to take in the humanities. They've changed it up a little bit, but either way, you're going to have to take some humanities courses. I had a lot of engineering friends sitting in philosophy that first year because everyone thinks they're a philosopher. We made it through, but it wasn't the easiest thing, actually. But I found that there was enough free space, and even I was double majoring too. There was enough free space in my schedule to take different things. So I wound up taking poetry classes. I wound up taking additional social science classes. And so I was able to get that engineering background and engineering thought, but able to take advantage of what else was offered at the university. So we aren't exactly a liberal arts college, but you can fit the things that you want to fit in and still get done with your traditional engineering at the same time.
Thanks, guys. We got some good questions in the queue that I'm going to get to. We also enabled the upvote possibility. So if you see a question, if any of our participants see a question they really like, you can hit that thumbs up on the Q&A, and we'll upvote some of those questions. I see a couple of people found it already. Okay, excellent. Dr. Hewlett, since we were talking about course load and maybe different types of courses, are there courses that maybe are struggle points for some of our prospective engineers at UD, or even from your background in your education as well? And perhaps it's in different programs, but what are some of the programs, some of the classes that students may traditionally struggle with a little more?
So traditionally, where students tend to struggle kind of across the board is in calculus. In particular, we see a pattern of students who come in very strong in math and science. In fact, so strong that maybe they have the AP scores necessary to skip calculus 1 and go to calculus 2. And what they learn pretty quickly is that high school calculus and college calculus are actually pretty different things. The subject is the same, but the pacing and the intensity, the level of what is expected of you as a student is different, very different. It is a higher level of onus on the student to learn. And so as a result, we see a lot of students struggling with that when they come to campus. So I actually recommend to students that unless you are like really, really solid in calculus, like you're getting 5s on the BC and you already have taken maybe some calculus outside of your high school, I generally recommend students to take calculus 1 if available at the university where they're going. The worst thing that happens is that you have a class that you've seen the material before and you're a little bit more comfortable in that course than the other ones, because the whole experience of starting college is a very, very big new experience. And I think that having something that you're a little bit more comfortable in isn't necessarily a bad thing. Of course, there's financial considerations there because you're paying for courses and whatnot, but that's typically my advice to students. So that's one place where students often get hung up. The other place I see where students get hung up is in a lot of our majors, students are required to take thermodynamics. And thermodynamics is one of those courses where you learn it once and you kind of say, I think I get it. And then you do it again and you say like, I think I get it. And then the third time you're like, okay, I don't really understand what's going on. I have faculty who have told me, I have professors who have been doing this their whole life, who are still like, yeah, I'm still learning about this thermodynamics. It's one of those courses that's just a fundamental part of understanding and being able to apply what we do as engineers, but it is challenging. It is challenging. And so my advice to students, and anytime they reach any kind of struggle point in classes, is as soon as you hit that struggle point in the course, get help early. Do not wait until you're midway through 3/4 of the semester to then realize that there's a problem. Your faculty are there to help you. They're there to make sure that you are succeeding and learning. And most universities, I know UD has this, like has structures in place for students to succeed. So anytime you hit any kind of struggle point, you should really be making moves to get help, be that getting tutoring, talking to faculty, talking to TAs, doing extra reading, whatever the case may be, it is to make sure that you're successful. Working with other people, that's a big one, and proven to be one of the things that makes successful engineers in college, is working with other students. So that's my advice to students about struggle points, is when you hit them, deal with them early, because engineering compounds, it builds on itself. And if you don't have the fundamental, the next step is going to be even harder.
Terrific. Thank you very much. I think we lost Andrew for a second. I'm sure he'll sign back on. And the next question was going to him and My'Kelya. So we'll direct this towards you. Can you walk us through a typical day, either if you haven't been at your new job long enough, or your old job? And there was a specific question about what it was like to be a female engineering student at Lafayette, and I think the workplace. I think that's a fair question as well, if you wouldn't mind going into that.
Yes, absolutely. So I'll speak, like I mentioned, I'm in a rotational program. So I'll talk about my first rotation and my second rotation as well. My first rotation, a typical day at work, I was responsible for monitoring our plants. So like I mentioned, I work at a place that sells air. So there's these big plants with these tall columns, and we basically suck the air in from outside. We squeeze it really tight, send it through a bunch of processes, and then we separate it into its different components, such as oxygen, and we'll sell it to hospitals. And so what I was responsible for was watching what the plant did every day. How hot is the weather outside? How hot are the pieces of equipment? And what's going on there? And so it was very desk oriented, very office oriented. I pretty much watched trends. If something went wrong, I would call the plant and say, hey, this is getting a little too hot. Is something wrong here? And that kind of thing. So it was more of an analyst role. So very desk oriented, not really field oriented, right? And now I'm in my second rotation, it's a little bit more of a hybrid. I am a zone engineer. So that means I'm responsible for all of the southern zone, hence me moving to Houston. And we're responsible for watching all of the plants down there and making sure that they don't fail. Because if a plant shuts down, a hospital doesn't get oxygen, which is pretty important right now in the middle of COVID. So typically what I'm doing in the morning is I'm waking up, I'm seeing what projects we have, what do we need to get done to order it, how much do the parts cost. And zone engineers are responsible for everything from figuring out what happened at the plant. So if something fails, we have to figure out why it failed, how much when it failed us, how much product we lost, who's responsible for it, how do we fix it, how do we get a new part, and then who do we ask for the money. So those are a lot of different pieces in there, and some of it is project management, some of it is technical engineering, and a lot of it is just learning organization and administrative skills. But a lot of this is also going to the plants. So like I mentioned, it's kind of a hybrid role. In about 3 weeks or so, I have to drive from Houston to Mississippi to go visit the plant that I'm responsible for. And so there's a lot of going in, seeing why things didn't work or why it did work, and then going back home and figuring out what it looks like on paper. I think there's something to be said. Office engineers is a term that's been thrown around a lot in the work world, is engineers who make the drawings and they say, hey, here you go, this works. And then the people who are out in the field say, no, it doesn't. And we're like, but the math works. And they're like, it doesn't matter, it doesn't work. So there's a lot of work dynamics with that. So what my role is kind of bringing those two together, figuring out if we say something works on a drawing, why doesn't it work in real life? And then learning how to mitigate those plant failures. And then as far as being a woman engineer, I love that question. I think it's changing a bit. Chemical engineering in particular has more women in it than most other engineering fields do. My class was split 50-50, which was the highest split at Lafayette for female to male ratio. And I think that it really depends on where you go. So I went to a liberal arts college, so there's just, different types of people at different schools. I would say that people kind of discuss instances with having, male counterparts typically talk louder, or they'll say the same answer in a deeper voice. Of course, I've had those kind of things happen to me, but what I was really cognizant of is that I wanted to be a feminine engineer. I did not want to become an engineer in a male-dominated field and become masculine or feel like I had to inhabit their traits. So I was very aware of that going into the role, that I wanted to be able to have my voice be heard without feeling like I had to talk like a man. And so that has had its pros and its cons, because sometimes when women speak softly, they're considered as being more timid or docile or not confident. And I've learned in the workplace that it just means that I have to say it with a little bit more bass in my voice, or I'll have to repeat myself. And I think people are quickly catching on that, women have valid thoughts, opinions, ideas, and oftentimes better than some of their male counterparts. And I've experienced that even in HR. In my previous role, I was business and marketing, which is also surprisingly more male dominated than I thought. And I had instances there where men would talk over me, or they just not listen to my ideas. And I just would calmly say in a very soft spoken voice, listen, this was my idea. I had this idea. I sent this to you. We discussed this in a meeting. Let's follow up on this, and just kind of take charge in the same way, but have the same kindness and respect that I wanted to communicate as a person, but bring that into my role as an engineer. So it's been a challenge being a female in all male dominated field. I have worked very almost exclusively with men so far, but it hasn't been an issue. I mean, in my new role, at least, it has not been an issue, but there are definitely challenges and small scale things that you see kind of play out several times throughout the day. So,
My'Kelya, I know Mrs. Rigner has her camera off, but she is beaming right now from all your responses, because that's the way you were at Archmere too. So, and a little plug for our powerful women that come out of Archmere. I remember our first year, when you went to Lafayette, we had an engineer go to Georgia Tech, Notre Dame, UCLA. It was a phenomenal year. That class was amazing, and we've had we just continually have diversity in terms of the interest in engineering, and powerhouses at the top of the class. So thanks for answering that question. I appreciate it. Andrew, if you're there, we had the question of kind of walking our participants through a typical day, if there is a typical day, and if there's good days and bad days, what do those look like?
So I just had a bad day. I just lost my network because my father-in-law decided to unplug everything. So that is one of my typical days. Let's start with a bad day. So a bad day is when everybody, because I'm a Boeing technical lead engineer, I am obligated or somewhat on the hook to provide consultation to a bunch of engineers in the floor. So a lot of test engineers and software engineers come up to me and ask me questions on how to approach a particular problem, how to understand the system, because I was on V-22 for approximately 16 years. So I understand somewhat of the mission systems architecture. So my bad day is when everybody starts coming up to me and asking me, oh, can you help me with this? Can you help me with that? And I'm sure, anybody, knows me, I'm willing to help. So that's my typical bad day. But, I enjoy it. I enjoy the challenges with everybody giving me a different, if you want to call it, task. But, I'm willing to help anybody that I can. But as far as a typical, so I'm mostly a consultant, if you will, but a typical engineer that was working at Boeing on V-22 mission systems go through a rigor of something called an agile process, where they start off the day and they come in, they turn on their laptops, open up their emails, check everything, and then they start their day off. And then in the agile process, we have stuff like stand-up meetings where they come to everybody in the team comes together and gives like a 5 to 10 minute status meeting, a status of what they did the previous day and what they plan to do today, the current day that they're working on. And then if there's any impediments, any problems with getting information to even doing any of the tasking, they ask around and ask the leads and all that kind of stuff, just to make sure everybody's on board and doing their thing. And then After that, then we start doing our individualized meetings where, everybody starts on, if there needs to develop requirements, they have a team for that. They have to develop design and code, they have a team for that. So they start doing their individual pieces that are necessary to get the job done. So our job is to make a quality software for our warfighters. So we basically have to make sure that all the requirements and code and software is tested properly before it goes on to the actual platform. I'm a software test engineer, so my main focus is to break things. So anything you ask me of me to, when someone asks me, hey, can you find a way to break this thing? I'm there to help you break it. I'm there to help at least find one thing wrong with the system. And if I can't find that one something, I'm not doing my job. So I'm paid to have fun to break things. Software, that is, not actually pieces of the aircraft, but actually I'm tasked to break and find ways of breaking the system. So yes, yeah.
And Andrew, we actually had a question at one point is how did your days change with the pandemic?
So we are fortunate that our job not necessarily is required to be on site. We have capabilities in our labs where we can do remote testing. So with the pandemic, a lot of people were working from home. And naturally, because of software, we can run our test procedures from home and execute the software using a bunch of simulation products that we produced to, test the system. Because when we test the system, we don't have the entire aircraft available. So we only have if we're testing software, we're just going to have the mission computer, and that's all we're going to be focusing on. We won't have the real displays, we won't have the real boxes on the aircraft. All those stuff are simulated. So on a typical day when we're during the COVID situation, we're at home actually writing our test procedures, designing our code, designing our requirements, and actually testing remotely. We also have simulation environments where at home we could actually test prior to going to the lab. But our main target is making sure the software works on our mission computers. So we focus on making sure our executions of our test procedures are on the real target. In the event that we do need to test the real hardware, where we have to test with the real displays by pushing buttons, or actually, talking through the radios, or talking intercommunications, using the real hardware with the real headsets, we go on site and actually do it. Of course, we have to make sure we social distance, we document our, who we've been with, how long we've been in the lab, and all those nice things. But we've been able to work very, I'll call it efficiently, actively, I guess, during this pandemic situation.
Thank you. I'm gonna pull Shannon in here. Shannon, we have probably several aspiring engineering applicants in terms of participants tonight, and so words of advice, things that you see or maybe CMU likes to see from its engineering applicants, whether it's a particular course load or extracurricular activity, test scores, anything like that. Also being sensitive though that if everybody does exactly the same thing, it's not gonna be a very fun class, and I'm sure you're gonna address that as well. So things that would better prepare me for an engineering and also might look good on an application. How about that?
Yeah, so I would say you can find the stats online. I can actually put some of them in the chat. Like we have a web page with these fancy sort of infographics and stuff like that, and you can see what GPAs people are coming in with, what's test scores. But what I will also say is we like to say at Carnegie Mellon that we have a holistic process, right? So I'm going to, of course, if I'm reading an engineering application, I want to make sure that a student is going to be able to do well in our courses, so that they have challenged themselves in courses that they could do well in the sciences and math and stuff like that. But then after that, I want to see who they are as a student and whether they fit with the university and whether they're going to add to our community. right? So you're going to be doing engineering work in your engineering classes, and that's great, but you're also going to be outside of your classes, interacting with a whole bunch of different types of people. We like to see people who are, giving back to their community, who are leaders, because as an engineer, those are things that we want to make sure are brought into the world as well, right? We want to make sure that you're doing great things and applying these scientific methods and findings, but also in ways that will help everybody else. And it's good if people in your class like you and people on campus like you as well. And that takes a whole bunch of different forms, right? So there's some students who sort of wake up and they think about engineering, and they eat and they think about engineering, and they dream about engineering. We have those students, but we also have students who are like, engineering's cool, but I want to do engineering so that I can do this thing after, or so I can help this group of people, or because I like the challenge, but I also like to play Quidditch on the cut on the weekends, right? So we have a whole bunch of different types of students, and I would just say the best thing is to really tell who you are. Don't try to, sometimes I'll see students who try to say like, oh, this is what an engineer must be, and they try to put that in their application. And the students who have the strongest applications are students who are really representing themselves. I really look for a bunch of different things. So just make sure you are who you are, and we'll see if you're a good fit for our university. And every university, most universities do that same thing. They want to bring a lot of different types of people onto campus.
Thank you, Shannon. I'm actually going to go around and ask this question of everybody, because again, we have 8th graders to high school juniors in our, as our participants, and their parents obviously too. How can they learn more about engineering? Maybe particularly they want to learn, what kind of engineering do I want to get into, or how can I take this webinar and say, hey, I learned a lot, I paid attention, but now I want to know more about particular areas of engineering. I want to help myself develop my why. And we have an honors engineering class at Archmere. We have an introduction to engineering class at Archmere. So they can take those courses down the line. But our 8th graders, our 9th graders, our 10th graders who aren't taking those courses yet, what's their, where are their opportunities to learn more about the field? Dr. Hewlett, I'll start with you on that one.
Yeah, so I think one of the things you can do if you're interested in engineering in general is you can actually come to UD, and you can actually take a tour at UD. And we do tours for any level of prospective students. I've given tours to freshmen in high school all the way to seniors who were trying to figure out what they wanted to do. And you can come in, you can pick a particular department that you're interested in and just take a tour of their facilities. Often they're either a faculty like myself or a student will give you a tour of the facilities and talk to you about what they do. And that's a great way to kind of see what actually happens on a college campus and see what an engineer might do at the college level. And I think that is a really useful thing. There's no charge. And again, you can do that at UD, even if you don't end up going to UD. Don't tell UD I told you this, but even if you don't end up going to UD, that's a nice way to kind of learn about the different ways, the different types of engineering. And so you can do that at the college level, just learning about in general what they do, or specific disciplines within the College of Engineering too. So yeah, you can go to our website and apply for apply to join and check out one of our tours. And we just started doing in-person tours again, which is exciting.
Actually, that's an excellent point. We talk to our juniors and even our seniors all the time that they can learn more about what they want when they're doing their college search, that the faculty are approachable when they're visiting, the administrations, and as well, students who are taking the programs right now. When they visit a campus, they've got everybody and their facilities at their fingertips, and it's a great opportunity. And I think it was a great message that, hey, we'll let anybody come check us out, right, Dr. Hewlett?
Yeah, absolutely. Yeah, absolutely.
Terrific.
I mean, hopefully you come and love what you see at UD. But even if you decide not to join us, like I think it's a really nice way to get you in the field, and that's part of my goal too. It's not just to get you to UD, but get more people involved in the field of engineering, because I think it's a wonderful field to be in.
Thank you, My'Kelya.
Yes, I was going to recommend going and visiting colleges, but also I think your best bet will be to talk to a current engineer, a student, find someone, it's going to sound crazy, but who has absolutely no stake in your life and does not care whether you succeed or fail, because they will give you an honest answer. So something I did and I really value is networking. I would go on LinkedIn and I'd find either Archmere alums or Lafayette alums, and I would reach out to them and say, "Hi, my name is, this is what I'm interested in. Do you have just 15 minutes to talk tomorrow and tell me about your career?" And most people are really, really welcoming and open to that option. And I think it's the best way because, first of all, when they're caught off guard, they're going to give you the honest answer. And then, secondly, they have no stake and they want you to do well. So they're going to tell you what they really think of it. And so you can talk to different types of engineers, reach out to a civil engineer, a mechanical engineer, a chemical engineer. And if the discipline in academic discipline is what you're focusing on, talk to a student. But if you want to know what their career is like, talk to someone who's already graduated. And I think you'll get a really good idea. And also do some research. I did a ton of research. I'm a big Googler. I love Google, the Bureau of Labor Statistics. I looked at the numbers. I wanted to know how much do the different disciplines make and what do the surveys say and things like that. And also, if you are a woman, take into consideration the gender gap in pay. I can share if anyone's interested later, but there is a survey that shows from the American Institute of Chemical Engineers. They do a survey every year of how much chemical engineers make, and they show the disparity between men and women. And then the age that it happens at is usually around childbearing age for women. And so I thought that was, and then we actually surpassed our male counterparts around 55 to 60, I think it is, which I'm not really sure why that happens, but it does give you some insight into what the pay looks like for that career as well.
My'Kelya, there's a great book by Brian Grazer called Curiosity Conversations that we were pitching to our juniors this year at Career Day, that, hey, just find somebody and ask to talk to them for 15, 20 minutes about their career, about their major, about a good day, about a bad day, all that stuff. So thanks for that phenomenal recommendation. How about you, Shannon? You have any recommendations?
Yeah, I think an important thing, just following up on what was just said, is looking at the jobs that you wind up doing after. I think it is a lot easier to get through any undergraduate program if you have that goal, right? You're saying, like, sometimes you're in that laboratory, you're mixing up powders and you're pressing pellets and you're like, why am I doing this? You're like, oh yeah, I want to work with the space agency to figure out how to synthesize titanium magnetite to look at Mars's crust, right? That's really cool. You tell your friends, like, oh, I worked with the Spanish space agency. It was great. And having that goal really helps in that. I think when I was choosing which engineering to do, I read like 4 paragraphs, and material science had the best paragraph. I was like, this sounds like something I want to do forever. That's probably not the best way to go about it, but it's always a good place to start. So looking what you want to do after, and just exploring these different things and the different job prospects that you can do after, really, I think, does help, and it gives you an idea of what you want to do. And then on the other side, look at what you like, right? If you're like, I really love biology and I really want to figure out how to apply it, then biomedical engineering might be the thing for you. If you're like, physics is where it's at, I don't understand why there are any other sciences, then hey, mechanical engineering might be for you, right? So you can come at it from both ways, and you might as well come at it from both ways as well.
Alex, what about you? How, if we have some aspiring engineers in the room, what would your recommendations be that they do early on in high school to try to learn more, to scratch that itch? Oh, Andrew, did you hear me?
Oh, I did. I thought you said Alex for some odd reason.
Oh, I mean, maybe I did misspeak. I apologize, Andrew.
Oh no. I was like, okay. No worries. So yes, definitely, all the suggestions that have been provided by the panelists is definitely excellent suggestions. Of course, I would love to give a plug to my first robotics teams. Joining first is probably a very good approach to understanding which part of engineering you want to go with. Certainly from, I do FTC, which is First Tech Challenge. We also have a Mode Robotics team for First Robotics competition. And that's at the high school level, where you get to actually work with real engineers into tackling a problem and using a game to kind of solve a problem. So you're kind of given, the requirements, you kind of give all the information you need to play the game, At the same time, they're opening, to you to like think about, okay, what do I need to do for this? Do I need to provide some CAD, some computer aided design, for mechanical design, for electrical design, for computer programming design? So we have those three aspects of it, and for our first robotics team. But we do get some things that I might not be interested in engineering, but I'm willing to do some other aspects of the program so that I kind of diversify a little bit. If they're interested in website design, okay, great, we do some website design. If they're interested in photography or things like that, we do have those options available. So I would encourage any student that is interested in engineering aspects or the sciences or math to join a first team, because we go through the networking, the communication, the teamwork. Definitely an important aspect of something that you would need for not just working with industry, but also working in a school environment where you have to work as a team in a project. So all of that comes into play when you start doing first robotics competitions and teams of high school or elementary or middle school students. So, and definitely Archmere has a team as well. And we do have some Archmere students and the FRC team as well. So,
My'Kelya, you had something to add?
Yes, I just wanted to add, I think the best way to prepare to be an engineer is to learn how to fail. I think that was the biggest lesson that I learned. I was not good at failing in high school. I think I got my first low grade, I think was like my junior year in an elective course. And I got a really bad grade. And I was like, really? In an elective class? And I was just devastated. I felt like my whole world shattered. And then I got to college and I was like, oh, I failed again. Oh, it's okay. The average was only 32 for the class. So, I mean, I did pretty good compared to the average. And getting used to, averages being a 32 on an exam. I've really learned that that was not only an engineering lesson, but a life lesson. But in particular, it really helps you with engineering, because when you learn how to fail, you learn a lot more. You learn what didn't work, which makes you think even harder. So find a place where when you fail, you're not so disappointed that you can't get back up, but you're disappointed enough that it'll drive you to figure out another way to do something. And I think the most creative times that I've had and the most innovative ways that I've been have been right after a failure. So learn how to fail now so that you don't, sit and cry for 10 days. Learn how to fail so you can get up and work harder.
Thank you. So
I would like to add to that if I may.
Absolutely.
So I definitely agree with the failure. That's how you learn. That's taking an opportunity to make a difference, make changes. I tell some of my engineers, my junior engineers, it's okay, to have the wrong answer. It's okay that you don't know the answer. And it's okay to ask questions, because you're new at this. Everybody's new at this. You're new at engineering. It's a new round, new everything. Ask questions, communicate, be able to talk through what you have in your mind, how you're thinking, how you do an approach. And then we try to tweak that approach so that they be able to, learn from the mistakes, be able to turn a problem into opportunity. So definitely echo that failure message, if you will.
Thanks, everybody. Great advice. We're coming up on an hour, and I know probably part of our participants are eager to see who the Eagles draft tonight. And get on that. So we want to be respectful of not only our participants' time, but of course your time, our panelists. So I'm going to open it up for some parting comments in terms of the things that you heard tonight that you'd like to reiterate, recommendations for young aspiring engineers, whether it be coursework or experiences or just words of wisdom. Shannon, if you want to get back into your philosophy days, that would be great too. So I'm going to start with you, Dr. Hewlett, in terms of just words of wisdom or anything from tonight that you'd like to reiterate.
Yeah, I think This has been a great panel, by the way. I think I've heard so many things that I already had kind of written down and things that I hadn't considered actually too. So that was really nice to hear. I think the words of wisdom I would leave is, if you're interested in engineering, do your research, get out there and check it out. Most engineers like to talk about what they do. I know most faculty love to talk about what they do. That's one of the reasons we become faculty, so we can talk about what we like to do. And so you have a wealth of resources available to learn about what it is to be an engineer. And I think if I was going to leave you with one thing about engineers, is one thing that I think it's often overlooked about engineering is that it is, in some respects, a creative process. There's a level of creativity to engineering that I think gets overlooked. People look at the rigors of math and science and think like, well, that's not really for me. I prefer to be more creative. You can be creative engineering. I can't tell you how many things have been created and discovered because people were observant and creative and figured out that something might work. And that is, I think, a real skill that I think if you are a creative person, you can probably actually do pretty well in engineering. We'll teach you the math and science. That's the thing that's what we're geared to do. But if you have some creativity, I think that's the thing that can really be a real boon to the engineering field. So I leave you with that.
Thank you very much. Shannon?
Yeah, I would say it's important to remember too that engineering is cool, right? Engineering is something that's super interesting, but it's not the end all and be all, right? So if you think that you're interested in engineering and that's something that really drives you, then definitely go for it and go try it. And if at the end of the day you find out that that's not for you, then it's okay to switch to other places too. I think something that was mentioned a little bit earlier was that you can use a lot of the skills to transfer to other areas. I have an engineering degree. I am not an engineer. But there's so many different things that I learned throughout my engineering experience on how to tackle problems that I use in a lot of different ways. And engineering is a wide field. I have a younger brother who's also an engineer, a different type of engineer. And the things that he loves about engineering and the engineering that he's doing now is different than what I was doing, right? And the things that I liked about engineering. So definitely take the chance, right? If it's something that you're interested in, go after it and try to tackle it at your speed. But make sure you're taking care of yourself and keeping in mind what you like and you don't like as you're going through.
Andrew?
Let's see, words of wisdom. Don't stress out. It is hard, but it's also rewarding. Definitely, when you start working in the, the industry world, it's definitely going to be, it feels like everything is on top of you, but it's, really not. You just have to take it day by day. And it's important that, if you need to talk with someone just to understand if you're doing the right approach, that's definitely a good thing to do. If you decide that you do want to become an engineer or wants to go through that aspects of it, there's hundreds of resources. I wouldn't say hundreds, but definitely I have students that basically went through things, and I could essentially provide that those students that went through, like for instance my robotics high school program, and they could talk with you about it. Certainly, if I have young engineers that are just brand new to the company, they can give their 2 cents on how they feel when they start their, the career, because it is definitely different, right? You've been doing education for the past, 18 years, 19 years, if you will, and then all of a sudden you go to college, and after you go to college, 4 years of that, then you go start working. It's a very big kind of a jump, just from doing all sorts of education, also working in the industry. So I would say take it bit by bit, day by day, take your time, don't stress out over it, and it will work out.
Thank you, Andrew. My'Kelya?
Yes. What I was thinking when you guys were talking is, this is great advice, but I always thought when I was going through school, it's crazy that the world asks us to figure out at 17 what we want to do for the rest of our lives. You're not going to have it figured out. So that would be my biggest piece of advice: is don't stress it. There's no way at 17 you're going to know what you're going to be or who you're going to be at 55, 65, or whatever have you. So I would just say, make a plan. If the plan doesn't work, fail. That's fine. Fall forward. Then you grow and then you network, and just keep doing that. Plan, fail, grow, network, repeat. And I just really think you'll be successful by doing that. and reach out to people. Like I love when people reach out to me if they have questions. I've done non-engineering. My first job was in business marketing and sales, and I have an engineering degree, so that was different. And then I decided to do something more technical. So I learned from that, and I moved on to something else. And there are tons of engineers with a similar experience. So if you ever have questions, I'm sure Mr. Baum and Ms. Frigner will share our contact information. Please reach out, ask questions. But like I said, it's okay. Plan, fall forward, grow, network, and repeat.
If I could take advantage of your time, though, because between Shannon and My'Kelya's answer, I love to ask one more bonus question in terms of what programs or majors or play nice with engineering. You know, where are there interdisciplinary options? And it may even take us to an answer over hopefully just 2 or 3 minutes to where do I go to my next job after my first engineering job, or what would make me more qualified for that job? Dr. Hewlett, could I start with you on that one?
Sure. Could you reiterate the question real quick? Sorry.
Sure. What kind of things, interdisciplinary options are there available in engineering, and how might that help me advance in an engineering field?
Yeah. So interdisciplinary work is, I think, becoming really a real popular. Like if you look at the trend and the way engineering has kind of changed over time, it's becoming more of an interdisciplinary field. So you can be an engineer, but not necessarily work in engineering. So for example, I have a friend who's a material scientist engineer, but he doesn't do that at all. He also got a degree in finance. And so he takes his engineering problem solving skills and he works for a hedge fund. And when they have investment and they want to invest in a technical company, he's the one that they turn to sort of analyze and understand sort of what that investment might look like, or is this a good investment, things like that. He uses his problem solving skills for that. Has never touched the material since 2002, right? Like he hasn't done that at all. But there's all kinds of ways in which, because as I think was alluded to before, like engineering teaches you a problem set, a way to problem solve, essentially. You learn how to approach a problem, how to iterate, as My'Kelya said, how to fail and how to learn from it, and then move on from there. And that's a skill that you can take anywhere. So I know people who have done medicine, who do finance, people who become artists, people who go into education like myself. We interface actually pretty well with a number of the other disciplines. At the practical level, like actually, finding time to do these things at the college level, sometimes that can be a tricky thing. Engineering is pretty prescriptive. But if it's something that's important to you and you have a particular goal in mind, as Shannon said before, figuring out those things becomes more doable, for sure. Also, I'll also say we actually have a student who right now who's doing material science and is doing art conservation, which actually are two things that actually I hadn't really thought of before, but she kind of found a way to kind of mesh them, because there's a lot of actual material science in the way we conserve and protect art and art pieces. So you can find a connection anywhere if you really want to.
That sounds fabulous. Anyone else want to take a crack at that question?
Yes, I can. At Lafayette, we actually do that all the time. Because it's a liberal arts, a lot of engineers. We actually have a program built in for engineers to get 2 degrees. You get one in engineering, and then you get a Bachelor of Arts in International Studies. So it happens a lot, and there's a program dedicated to it. So I think business a lot of times goes with engineering. I know a ton of engineers who minor in business, economics, or finance or something of the sort. But I actually was told when I went into school, I don't know if it was the best advice, but it was major in something that'll make you money and then minor in something you love. I don't think that's a good concept. You should like what you do. I want to say that. But I do like that I minored in something that I really liked. I minored in French and I really enjoyed it. It gave me balance. And it also has worked for me in the work world because the company that I work for is a French company. And because I am able to speak a little bit of French, they actually have me on their radar to do things with them in France. And so I think that can take you a step as well. International parts of engineering can be really helpful.
Anyone else?
Yep. I'd just like to, reiterate having a technical background can be extremely helpful in a lot of different ways. Like I think we definitely hammered home the problem solving aspect, but even just knowing in general how long things take and how possible it is to do something really helps. So there's a double major program here at the university called Engineering and Public Policy. And the basic idea is sometimes you have to make policy decisions on technical questions, right? And a lot of policymakers don't have the technical background. So they're like, oh, how long is it going to take to clean up this thing? And they're just pulling at straws, right? But you as an engineer can say like, hey, like this is how long reasonably it'll take. And this is how you go about it. And sort of bridging those gaps can help. So you can use some of your engineering knowledge to make policy decisions. That's the double major I got. So there's a lot of different ways you can put engineering into different places. And yeah, so having that technical background really does help in a lot of different ways.
Andrew, can we get you to chime in for the finale?
So yeah, I did mention earlier that we do have managers that have a technical background. So some engineers went through the notion of, do I want to go to the technical path or do I want to go to the managerial path? And a lot of them started deciding, okay, I want to end up to be in a managerial path, and we try to provide some avenues, whether it's talking with a mentor. We do have mentor-mentees at work that would basically go through the rigor of what the type of aspects are involved in a manager, or what we do have technical fellows that talks about the technical aspects of being a technical fellow, and the technical aspects of the everyday engineering design principles. So so we go through that path, and you decide, okay, you want to go to that route. So we do have, avenues where, we do some rotations and say, hey, let's try this and see if you like this. If you don't like it, you can always move to somewhere else. So it gives you like a little bit of flexibility to make sure that you are going to the right path in your career, and at the same time, try to understand if that's the right thing you want to do. So,
Thank you, Andrew. If we were in person, which I hope the next time we do at Y Engineering, we have all of you at Archmere, I know you'd get a nice big round of applause, and we'd probably have you on campus for like another 45 minutes as people come up and ask you question after question after question. So I do miss that opportunity, but I wanted to thank all of you for being so generous with your time as well as your expertise. This was a phenomenal panel. And I know Mrs. Rigner, Mr. Duffy, and I are going to get a lot of questions tomorrow morning in terms of things to answer. But as we move forward, our students in the audience, we heard it over and over again, talk to people. My'Kelya recommended just send somebody an email, say, I'd like to talk to you. I'd like to talk about your profession. Dr. Hewlett invited you to UD, right? And I know other people are more than happy to answer questions. So if our engineers are supposed to be curious, so let's be curious about the profession, find out more about it, and certainly stop in the college counseling office if you have any follow-up questions. Guys, thank you again. I can't thank you enough. It was another phenomenal program. And for all of our participants, we'll post this eventually, the recording eventually on our YouTube channel. So if you want to double check any information that you heard, we'll allow you to do that. Again, thank you very much, everybody. Have a wonderful evening. I hope to see everybody again soon. Take care.